And we are back. Hello everyone, welcome back to 5 Minutes Code channel where I will be explaining the solution of every problem of lead code and geeks for geeks. So, without wasting any time, let's get started. Today's problem is word search, which is marked as a medium level problem. Let's find out what we will be given into this problem and what we have to do. So, we will be given two parameters. First one is a matrix mat of character type, and it's a 2D matrix of character type, and another one is a string word. Okay, all right. And what we have to do is pretty simple. We are given a word. You can see this word we are given, and we have to check if this word is present in this matrix or not. And if it is present, we will simply return true, and if it is not present, we will return false. So this is what we have to do. Now you will be thinking ki yeah, we are given a character matrix, so how a word can be present in a character matrix? So basically we have to form words with these characters like GEEK, GST. In this way, GEL and GET. In this way, we can form many words with this. And basically, we have to check if the given word, which is this, is present in this matrix. In this way, we will return true. If this word is not present by any combination, we will return false. Okay, all right. So there are few conditions for this word. Basically, we can either go horizontal or vertical. So like from G, I can either go to this E, I can go to this K, I can go to this S, and I can go to this E. But I cannot go from G to T. I cannot go. Okay. So this is the first character, first condition. We can only move horizontally or vertically, and we cannot move diagonally. Okay. All right. I think this first condition will be very, very correct to you, clear to you. And after that, second condition is basically same cell cannot be used more than once. Okay. What does this mean? This means suppose I have to get the word G, GEG. We have to check if this word is present or not. Okay, all right. So basically, I will first of all go to this G. Let's suppose I am currently at this G. I will go to any E. So this is my E. G is present, and I cannot come back simply. I cannot come back and say, okay, I got G. So I have got a word GEG. No, because G is already traversed once. It is used once. We cannot use it again. So we have to check for a other G. If any other G is present, then only this word is present. Otherwise, it is not present. Okay. So I think this condition is also clear to you. So there are only these two conditions. And if we can find a word, we will simply return true. Okay. All right. So now I think the problem statement will be very, very clear to you. And let's think of the approach. So first approach, and the only approach here is basically to try all the possible ways. Okay. To try all the possible ways. Because look, if currently, let's suppose I am at G, I have to see if get is present or not, or we have to see if gel is present or not. So there is no algorithm for it. Like there is no sure path for it. We have to check all the possibilities. I will simply go first time G to E. Okay, and then from E also I have a opportunity to go to this E, GEE, which is not equal to GEL. Okay, after that I have an opportunity to go to here GET, which is not equal to L. Again come back. So now I also want to go to up, but up there is no way. Okay, so with this E we cannot find our gel. Okay, I will come back to here. Okay, again I started from G and I have backtracked to G. Basically on the upper side there is no possible way. Okay, all right. After that what I will do, I will now simply move to the K, right side, GK. GE I have to, like GE is my word starting, and it is GK. Okay, no issue. Its K is not present, fine. So we will simply return back. Okay, now G I will move to left. GS and GE, no, it is not matching. Okay, again come back, backtrack. Again G is there. Now I will go to down. Okay, GE, yes, G is matching. So now again I have three options to go, either to left, either to go down, or to go right. Okay, let's suppose I first of all go down. So on going down, I will simply go out of the matrix. So I will simply backtrack, it's not correct. Now I will go to the left side, GE, and now the word is what become GEL, which is my required word. So I will simply return true here, and if I got true from this L, I will again send true here, and G, if I got true here, I will simply return it back to the is world exist function. In this way we have to solve this approach, and it's a simple classic backtracking problem. Okay, all right, let's quickly see this with the approach, and I think I have already explained the approach, but let's see one more time in OneNote thoroughly. Okay, all right, let's quickly move to OneNote here. So our word is GEEK. What approach I am going to do? I will simply look. I will only start with those characters, those cells. Like first character should match, na. Suppose there is no. First of all, I will traverse the whole matrix one by one. Okay. So first of all, I got T. So basically, if first character is not matching with the first character of word, it's no need to go further. No need to go further because T is not matching with G. So if I go to a T E G E, it will not match. So there is no chance. There is no way to move. So okay, T with T we cannot go. With E and G it is not matching. We cannot go. E and G it is not matching. We cannot go. S not matching. G, yes, this is the G, like basically starting, and this is also G. Okay, so first character is matching. Now when the first character will match, I will simply move to the backtracking approach. Backtracking function is there, and where I will be passing what I will be passing. First one is my matrix. First thing is matrix, which I will be passing. Second one is a visited array, which will basically check if this cell is visited once or not. Otherwise there is no way to check, and I will simply go to G and then E G G E G G E G in this way, which is wrong. We can only visit cell once, use cell only once, so that's why we need visit array. Okay, all right, and after that I will pass this coordinates of this, which is 1 comma 1 currently. Okay, and currently I'm checking for the zero character. I'm currently checking for the zero character. Okay, so how many things I'm passing? Matrix, ij, current position, current index of the word, and we will pass the word and the visit array. Okay, all right, now after that, look, G and G is matching. Okay, all right, now I have four ways. With this G I have four ways to go. Okay, let's first of all move to the upside. Okay, now again I will call the function, again I will call the recursive function, but this time I am going upside. So my current, look, current was 1 comma 1 I comma j. Now if I will move to up, if you remember, my row number will decrease. Row number will decrease, so basically I will do I minus 1 comma j. Again we will call the recursive function. I hope you guys are able to visualize this once, and after that I'm going to write the code as well. Okay, so now I move to this E. Okay, so if I will check ki yaar my current word, look, 0 0 0 index is matched, so I will go to this E. Okay, so I will check yaar on going top my character is E, and this character is also E. So okay, two characters I have matched, and now we have to check more characters, like two more characters are remaining now. So again I have three ways. From here again I have three ways, either to go left, either to go right, or to go top. I will not go down because on down visited array of this G is marked as true and it will basically return. So no need to go. And after that, in this way, will go move upside. On moving upside, again I minus 1 will be there, but we have moved out of the matrix, so we will simply return. Okay. Now from here, from upside, I got false. What I will do? I will move to left side now. So on moving left, what I will do? Look, on moving from E to T, my row number is same, but my column is decreasing. So what I will do? I comma j minus 1. Very, very simple it is. Okay. I comma j minus 1. So yeah, look, I have to check this G and E are matched. I have to match this E. Okay, all right. But yeah, this is T and this is E, which is not matching. So no need to go check for the more characters from this T, because if T is not matching, after that again nothing will match, so I will simply return false here. From upside I got false, from this side also I got false. There is only one way to go, which is right. On moving right, what I will do? I comma j plus 1. Okay, so now this is the new character E, and I have to also get the my current character which I have to check is also E. Okay, I have got like G E E are matched, and now only K is remaining to match. Okay, all right, let's move this to K. So when I need to check K from this E, I have four ways. Like after, like every time I will have four ways. Either to move back. On moving back, if you remember, we are using visit array, and I have marked this E as visited already. So now on moving back, I will check, yeah, E is visited. So return false. basically I will again come back to E. Basically it means there is no possibility from the left. On top and on right we are out of the bound, so no possibility for that as well. Let's go to down. On moving down, how can we move to down? Very simple it is. If I'm currently at E with my ij and I'm moving down, on moving down column remains same but row increases. So my new row will be I plus 1 comma j. Okay, in this way basically 4 ways are there to go. So I plus 1 j, and now new character is coming which is k, and I have to also, I was also in search of k, so k are matched again. Now this pointer will move further to here. Again recursive function will be called. Now I will check ki yaar my word, all the characters of word are found. All the characters of world are found. I will simply return true, and this true will be returned to E. From E, this true will be returned here, and from here this true will be returned here, and here I will return simply back to the function that true, this word is present. Okay, so very simple backtracking solution is this, and when I will write the code of it, this will become crystal clear to you. So that let's move on to the coding section. And yeah, guys, before writing the code, if you have loved the explanation till this point, please subscribe the channel and like the video, because it will really motivate me. And comment down if you are a regular viewer, and if you want anything to be improved, please comment down, then only I will get to know and improve. So please comment down what are your views, what are your views on my teaching. Okay, all right. Too much is there, so let's simply go. Simply, if you remember, first thing I told, I will simply iterate over this whole matrix. To iterate over this whole matrix, I will use two for nested loops. So simply use that. For int I is equal to 0, I is less than mat dot length I plus plus, and for int j is equal to 0, j is less than mat of 0 dot length j plus plus. Okay, all right. Now I have to basically look, if my first character will match, then only I have to check recursively for all the remaining characters. But if my first character is not matching, no need to check for other character. Okay, so how can I check if my first character is matching or not? Simply, if mat of ij, which is my currently I am at mat ij, is equal to world dot char at 0, world dot char at 0, it means ki if first character is matching, I will recursively check all the remaining characters. Okay, all right. And how can I check? Basically for this we have to also make a boolean visited array, visited 2D matrix, which will basically keep count of if I have visited this cell earlier or not. Let's quickly make that. Boolean visit is equal to new boolean of same mat dot length and mat 0 dot length. Okay, all right. So this is just a boolean way. And look, if I will again move to this for loop again, so this boolean visit will be again constructed so that it does not have any value of the previous calculations. Okay, just to start fresh. All right. And now let's simply make a function, check, solve, anything you can make. I basically prefer check writing more. I don't know why. First thing I will pass my mat. After that I will pass my I comma j, basically current location I comma j, current character of this word which I have to check, which is 0. Okay, and after that I have to pass this word as well, and one more thing which I have to pass is visit. Okay, so these things I have to pass, and uh, if it will return me either this word is present or not. So if this is returning true, simply return true. Basically means this whole world is found. We are in this check function, we are going to track the whole world. So if I get whole world, we will simply return true. It means this was present. And otherwise, after coming out of this for loop here, I will simply return false, meaning this word was not present at all. This word which we have to search is not present at all. Okay, all right. Very easy this is. And now let's quickly write the code to check. First thing first, what I will do, mat. So just simply copy this. We are going to use this string mat is there, and after that int I is there, int j is there, and int let's say this is the index of the word which we are have to search now. Okay, index of this word. So and after that I am passing string word, and after that I have to pass this boolean visit array. Okay, all right. I think we are good till this point, and now just simply first thing, base condition. What will be the base condition? If you remember, if yeah my index is equal to world dot length, it means I have traverse the whole world. So if index is equal to world dot length, it means what? It means the whole world is traversed now, and let's suppose for this geek, whole geek is traversed, so it means this world is present, then only we can traverse the whole world. So I will simply return true. Okay, all right. And also we can return false. So what are the conditions for that? First one is if I have moved out of the bound. If I moved out of the bound, I will simply return false. How can I check if I have moved out of the bound? If my I is less than 0, or my j is less than 0, or I is greater than equal to mat dot length, or j is greater than equal to mat 0 dot length. Okay, these are the basically checks for out of the bound, if I'm moving out of the bound of this matrix. Okay, other than that, if the current cell which I have moved in this check function, if this is already visited, how can I check that? Very simply write visit I j. If this visit ij will be true, it means it is already visited. Okay, also one more thing, if this, let's suppose one more case is there, here suppose I am searching for this e character, and this current character of ij is not equal to e, so then again I will return false, basically meaning ki we cannot go further, so how I'm going to write that? Simply let's copy this. Let's delete this. Matrix of ij not equal to world dot char at index. It means ki yaar, if any of these conditions is true, it means ki we cannot move further. I will simply return false. Okay, I hope I've already explained this much. Basically these are the conditions for out of bound. This is condition for already visited cell. This cell was already visited and I'm coming back, and this is the condition ki yaar, which the character which I'm searching is not equal to current character of this matrix, so we have to return false. Other than that, if I'm coming to 58 line, it means index, till this index we are done, and now what I will do, I will simply mark first of all visit ij is equal to true. Okay, visit ij is equal to true. Okay, all right. And after that, what I have to do, I have to move further ki yaar look, till this e, let's suppose till this e we are done. So now I have to again check for the remaining character, which is this k. So again we have to either move the up left side, up side, right side, down side. How we can do that? Let's quickly see. So for that, look, very simple is it. It is, if I am moving, check, copy this, and matrix I will pass. Let's suppose I'm checking for the left. On checking left, on moving to the left, you can see my row is same but column is decreasing. Let's do that. I row is same, column is decreasing, and index +1, and after that word comma visit. Why I'm doing index +1? Basically means this index is already checked here. We have already checked this character is equal to or not, so now I have to check for index +1. And let's copy this 4 times because we will be needing it. So either I can move look, many possibilities are there, isn't? Either I can move left or I can move right. On moving right, it will be j+1, or we can move downside. On moving downside from e to k, our row will increase. Let's increase the row I+1, and j will be same, so j as it is. And after that, one more thing is there. Either I can move upside. On moving upside, my row will decrease and j will be same. So if any of these conditions are true, it means we have got the whole world because we are using recursively. I will simply return true. All right. Otherwise, what I will do, I will simply mark this visited. Backtrack. Let's backtrack. So on backtrack, whatever changes I am doing, I have to revert it. So only one change we are doing, marking visit ij is equal to true. So now I will mark it as false, and I will return false. Basically meaning ki, let's suppose I come at t. This is the my t, and now I have come here. So uh, yeah, let's suppose I am currently at e. Okay, and on e, like e, we are matched with the current index. Let's suppose this any index currently we are searching for, and it is matching. So now I will move to the left side. First of all, let's move to left, move to right, move to up, and move to down. So on moving all four, we cannot find the word, so I have to backtrack. I have to backtrack and come back. So on backtracking, if t was marked as visited, we will remove it and we will return false. Basically, returning false means कि this character was not found in the left side, on the right side in this way. Okay, all right. So that is it. I think it should get accepted. Let's quickly try to compile this. And if you have loved the explanation till this point, please subscribe the channel and like the video. And I am giving my full efforts, so it's on to you. So comment down, subscribe the channel, like the video, and this is getting accepted. So yeah, that's it for today. I'm going to see you again tomorrow. Till then, keep on coding and bye.